So the first type of nuclear reaction we're going to talk about is nuclear fission. Nuclear fission occurs when you split a larger nuclei into smaller nuclei. As we talked about just a minute ago, that process is going to release energy. So here's the reaction that I promised. You have uranium-235. Okay, it gets hit by a neutron. That neutron makes its way into the nucleus for just a brief moment in time. It becomes uranium-236. Uranium-236, really unstable. It breaks apart. It releases gamma rays, which are high energy electromagnetic waves. And you get a strontium nucleus and a xenon nucleus, and a couple of neutrons. The gamma rays are the energy that's released. And so when this nuclei breaks apart, energy comes out in as really high energy electromagnetic radiation. Really high energy light, if you will. You also have some nuclei left over, but you also have some neutrons left over. And those neutrons are going to move. Most of the energy that's released from this splitting, from this fission, is given to the kinetic energy of the daughter nuclei and those neutrons. But there's still some left over. That leftover energy gets released as electromagnetic radiation. This is the same reaction that was used in the atomic bomb at the end of World War II. We're going to talk a little bit about that. But it's also the same process that's used in nuclear reactors. It's not always uranium. There's lots of other fuels that you can use. Maybe not lots, but some. But it is always the same type of fission process. You break the nuclei apart. You wind up with some daughter nuclei and some extra particles. And these neutrons are on their way to hit the next uranium nucleus. So in 1939, scientists figured out a way that they could use that free neutron and split a uranium-235 nuclei into two smaller nuclei. And when it does that, it releases a whole bunch of energy, as well as all of those extra neutrons. The neutrons that got generated would then go and hit another nucleus, generating more neutrons, and so on. And this process continues as what's called a chain reaction until you use up all of that uranium. Okay, so you have one neutron that hits, it breaks down into this smaller nuclei, but it also sends off two more neutrons, which hit another nucleus. And every time this happens, you get a bunch of energy released at every point. And so if it happens really, really, really fast, if you can trigger all of this reaction to just go through instantly, well, what you get is a huge explosion. You get an atomic bomb. These are how that process works. This is how atomic bombs work. With splitting apart nuclei and the energy that comes about from that process. All you've got to do is force this to happen once, and it'll just keep going. And if it goes really fast, it'll explode.